Okay, so we're a carpool team. I'm Kristen, and this is Ed, Bruno, and Josh. We made a mobile app for Carpool. So if you don't know what Carpool is, it's a nonprofit organization here at Texas A&M that was started in 1999. We offer free rides to people in the Bryan College Station area on Thursday, Friday, and Saturday nights from 10 p.m. to 3 a.m. with the main purpose of reducing the number of drunk drivers and helping students and non-students obtain safe rides home at the end of the night. Carpool's vision is to become one of the most effective designated driver programs in the nation. However, their current operations are a little outdated and very inefficient. Right now, if I wanted to call in and get a ride from Carpool, I would have to find their number, give them a call, tell them my name, phone number, pickup destination, and drop-off location, and hope that they heard it all correctly. And they would tell me that a driver is going to come pick me up. But I get to wait for a really long period of time without having any information on if the driver's on his way or if he's nearby or at my destination. So obviously some of the main problems with this are that it's not always easy to make a call, especially if you're in a loud or crowded area. There also are very long wait times, and if you're at Northgate, which is our bar area, you also have to stand in a long physical line, which is kind of shown as this cluster of people in this picture. But this is because Carpool, the people running Carpool, only give you rides based on when you requested a ride. They don't really take into any consideration into where your end destination is and grouping with people who are in similar locations. And there's also no way to be updated, no way to know where your driver is. So our solution is to create an iOS mobile application with a driver's side and passenger side that incorporates a complex algorithm for matching passengers with drivers and really drives efficiency and makes the whole process a lot more convenient for users. So how does this improve Carpool's current operations? It's a lot more convenient. There's no need for calling in. You can simply use our app to request a ride really quickly and easily. You can also be updated with real-time information on where your driver is so that you know when to go outside and meet your driver. It's a lot more efficient due to our algorithm, and it will allow you to not wait nearly as long, and it will also allow Carpool to service a lot more rides throughout the duration of the night. So once again, less wait times, no physical lines, and you can allow your friends to join your ride if they're going to your same end destination. And then we also wanted to lay out the main differences between our application and other ride-sharing services such as Uber and Lyft. And one of the main things is that our service is free, and the drivers are approved students from Texas A&M University. So a lot of people think it's safer instead of riding with a stranger. We also use a different optimized algorithm that we'll go over in a little while. And a neat feature of our application is that we allow users to select to be dropped off last if they don't want others in the car to know where their home is, because one of the features that Carpool has is they usually drop females off after males, so that the males don't know where the females live and go back to their house after being dropped off. So we incorporated that feature into our app, and our application solves all of Carpool's current problems.
So I'm going to go over the current demo video that we have. It's a simulation that we ran. So before I start the video, what you see on the right-hand side is the driver's view. On the left-hand side is the passengers. I'm going to walk you guys through real quick. So the driver is chosen to log in to his to her account, which is Kristen in this instant, and is choosing the number of passengers that she gets to take in her car. She logs into her account. Meanwhile, Ed on the other side has just chosen to get a ride, and he said that he's got 2 additional passengers with him, and he chooses the option to not get dropped off last, and he goes through the process of choosing a ride. So the driver's waiting for rides right now. He currently doesn't have any rides out there. Meanwhile, on the left-hand side, the passenger has picked his pickup location and now is searching for a drop-off place. He's going to choose 3526 Kenyon Drive, and he's going to College Station, Texas, and going to go choose continue. That shows the marker as to where the address is, which the passenger then confirms by hitting the continue button, and ends up at our final confirmation page where it shows you where your pickup location is and where your end location is, and there's a set of terms that the user is now agreeing to. And as soon as he clicks confirm, you will notice that now the driver's side of the app populates and shows where to pick up the passenger and where. So the red marker that you see is the final destination. The purple is where the passenger is going to be picked up. The green is where the driver currently is. So through this simulation, the driver goes and picks up this passenger, clicks reach destination at the bottom of the screen as you see, and now it's down to 2 markers. Picks him up from the spot and now zooms again in. On the left-hand side, as you see, the passenger can see the real-time position of where the driver is. So he or she can be updated to knowing how far away the driver is from their specific location. And finally, the driver gets to the end location and clicks reach destination and then clicks get routes again. As you see, the passenger gets now finally dropped off, and it takes a few seconds here for our server to get the data, and the driver or the passenger gets an update for, hey, this is the end of your ride, here's a summary. You can now rate your ride, do the stuff, and the driver logs off, and the passenger can give his or her final input and submit. And on the next video is the web portal. We'll get to that later.
So here's our system architecture. So our data is stored on MongoDB. We have the passenger and driver databases, where all the information about the passenger is stored, their location, where they want to be picked up, how many passengers they have, whether or not they want to be dropped off last, and all the driver stuff is also in there. I'll go over the data model later. Our server / API is written in Node, so that the admin web portal and the mobile application use the API in order to write data to the database and read data from the database, as is requested.
So we started off trying to get user feedback to see how should we get towards the details that we need to make our app. And we interviewed 66 total people, of which 45 of them were undergrad students, 4 of us are undergrads, so it's easiest for us to get towards 45 undergrad students. 12 of them were grad students and 9 of them were alumni. And of that, 13 of those members were Carpool members, and we wanted to use this feedback, which in the next couple slides will show you as to what we did with that. The next thing we also realized was, of the people we interviewed, 38 of them have used Carpool before, 49 of them have used the other Lyft sharing services, Uber, Lyft, and 24 of them have used both of them, which leaves out 3 people who have not used ride-sharing services at all. And finally, in regards to that, we were able to get user-driven design from this feedback. As Kristen previously showed you an image of the long lines that were there, this is a virtual queue. You could see where you are, how long it would take for you to get picked up. It would be real-time updates of the driver's location, as we'd shown you in the demo, as to where the driver is located currently. It notifies you when the driver is close by. The main thing is also to be able to contact Carpool. We had a donate button and a call button so that you could get in touch with them, or in this instance, just be able to request a ride directly from the app itself. Carpool runs off of donations. The organization runs off donations, and we thought that if you, as a user, liked your ride, you could directly donate from the app itself, and that leads you to the donate option and feedback. Finally, it needs to be drunk person friendly. As Kristen mentioned, that it's a nighttime service, and it was built to make sure that people get home safely at night. And we minimize the amount of clicks that a passenger ought to do to be able to go through the process. And as you saw in the demo, it ranges from 5 to 7 clicks at most.
So in addition to the interviews that Josh was talking about, which we performed throughout design, development, and testing, we also conducted interviews or user studies once we had an app that we could show people and get feedback on that. And to conduct these user studies, we had a pre-study questionnaire followed by a demo and then another post-study questionnaire to really measure people's reactions to our application. And there were 2 questions in particular that really measured people's reactions well, and one of these questions was, how likely are you to use a mobile app for Carpool? And before we showed them the demo or our app at all, the responses were positive, but only okay. And once we had showed people the app working and kind of went over the underlying algorithms to increase its efficiency, people really shifted to the right towards extremely likely, which showed that they liked our app and would be inclined to use it. Another question that we got really great results for, we asked people which services they were more likely to use between Carpool, taxis, and services such as Uber and Lyft. And originally, we had 55% of our users say that they would prefer Uber or Lyft. Only 40% chose Carpool, and 5% chose taxi services. But after the demo, after showing them everything again, we had a huge shift towards Carpool. 75% said that they would prefer to use Carpool. We had no more taxi users, and 25% said that they would still use Uber, which again shows that people really liked the app that we created for Carpool and really saw how convenient it was to use here in College Station.
So the methods that we use in order to solve these problems. So of course we created an iOS application, and the underlying algorithm is based on the traveling salesman problem, which if you don't know what that is, it takes in a collection of points and it outputs a score of minimal length across those points. So we use that when choosing the routes that the driver will take in order to reach all the pickup and drop-off locations of the passenger. So one of the main problems is minimizing passenger wait time. So we model this by the summation of the rides of everyone who is in the car, a particular driver's car, and then we optimize that. Then we add the time that it takes for the duration of the rides of everyone in the passenger queues, and then we add the time that it takes, extra time that it may take if a passenger is skipped along the way, which I'll explain in a second. So high-level algorithm explanation. First, we find the driver who's closest to the passenger based on GPS coordinates. And then once that is found, if that driver's passenger queue is full, if it's not full, then we stick them into the passenger queue. If it is full, then we put them into the waiting queue. And then finally, we optimize those drive routes to make sure that everything is hit in the most optimal way at the end.
This is an implementation of the algorithm. In this instance, we've got 3 passengers seated in a car. The car's current position is at Agronomy Road. As you can see that the red is supposed to signify the destinations. There's a passenger within the queue, Daniel specifically. Next slide. So what happens, the first thing is the car goes and drops off Adam at his specific location, which was 3806 Oakland Street. This leaves an extra spot in the driver's vehicle when he chose to drive 3 passengers. And as you can see that there's a star on this map, which signifies the pickup location of Daniel. It wouldn't make sense for us to have to drop all of them off and then go pick up Daniel and then go to his end destination, which is further down here. So in the next step, you would see that in our database, passenger 3, Daniel, gets updated to be picked up in front of Chris. And as Ed had just mentioned, we have has been skipped, part of our algorithm, which only allows Chris to be skipped this one time. So this would make sure that if there was another person here, Fred, for instance, if you were to get picked up, if his location to get picked up here, Daniel would not, or Chris would not be skipped again, in order to make sure that it's not a loop that goes on forever and Chris is not stuck in the vehicle. And this is how our algorithm's been implemented.
So here's our data model. So the 2 main classes that we use are the driver and the passenger. So the driver has a username and password, which are used for authentication. So not just anyone could log into the application as a driver and start messing with people or with the system or anything. We have the current latitude and the current longitude, which are updated periodically in order to show passengers where the driver is located and to match new passengers to a driver as they are requesting rides. The seats available in the car, we don't want to put more passengers in the car than the car has room for. So the passengers currently in the car, the passengers that are currently assigned to this driver. A passenger queue, so if the car is full, you put them in the passenger queue, and they are added into the car as spots open up. Passenger routes, which are the optimized route that the driver is to take when they're driving, and has been bought, which is set to true or false depending on if a passenger is in there that wants to be dropped off last. And the passenger model, their name, phone number, their pickup location, their drop-off location, which driver they're assigned to, whether or not they've been skipped, and dropped off, whether or not they want to be dropped off last, which has to do, if they do, then we lock the car. If they don't, we don't lock the car.
And the software and tools we used to complete our project was, for the iOS app, we used Xcode. For the maps, we used the Google Maps API to draw the maps and all the markers. We used Almofire. That's a framework to allow us to communicate back to our server that was written in Node.js with the MongoDB backend. And we used GitHub for just versioning. And of course, the phones had GPS for the passengers and the drivers to select their pickup locations. So our team structure here, of course, we have Dr. Tracy Hammond, a professor. We have Cassandra Abdullah, she was our TA. And here in the back, we also have Siddhartha Karthik. He was our mentor. And then finally, we have us, which are the developers. Ed worked mainly on the server API, also worked with the database to implement the algorithm. Kristen worked on the UI of the mobile app. Josh worked on the algorithm and the web portal. And I worked on the back end of the mobile application. So we had some ethical concerns as we were completing our project here. We wanted to allow our passengers to remain anonymous. We mainly did this by locking the car if they did want to be dropped off last, meaning they didn't want anyone else to know where they live. So that's how we kept the passengers safe. We securely store the driver data. Only authorized users can access their location as they're being updated, and we maintain confidentiality during our user studies. And for future work, if we had more time, we would like to have extended this to work for Android phones and Windows phones, just to hit a wider user base. We would have liked to integrate Twilio, which is a SMS service so we could text our passengers and get regular updates or anything like that. And finally, we would have liked to extend our project into a platform for more organizations to use. This would be useful for maybe another university who wants to start up their own Carpool program. We